introduction into trigonometry. Don't worry, we're doing nothing with angles today because that's gross. We're just going over ratios. So first we're going to look at this. We're going to start and identify the parts of a right triangle. All right. So looking at this, I think I have your y and the bottom one down here and your x over here. So when we're looking at something like this, if there is this kind of half circle or part circle, that's just saying we're looking at that angle. And whatever variable is next to it, that's just going to be the name of our angle, like the placeholder, just like using x in a, in any equation trying to solve for it. But today, we're just focusing on the ratios of the sides. Before we get into trig, can anyone tell me what a ratio is in general? Like, what does that mean?
Relationship.
Yeah, like the relationship between two things, right? So like, for example, there's 5 of us here, and we only have 1 biology major, right? So the ratio would be 1 biology major to 4 people who do something else, right? All right, so we're gonna label the sides of this, and this is gonna help us understand these ratios a little bit better and give us a way to describe it. So first I wanna look at this, because we base all of our sides on where this right angle is. So we know it's a right angle, and if you look at your notes, I think I have a spot for this. We know it's a right angle because it has this square in it, right here. Can anybody tell me how many degrees every single right angle that has ever existed has?
This kind of
90, perfect. So 90, and then I wrote degrees on your note-taking guide, but we all know that it looks like this little circle that goes above, right? Still don't know how to type it in on a keyboard. Hopefully I'll find out one day. Okay, so now we're gonna go ahead and label the sides. So we're not gonna worry about these 2 angles first, because the one side we always know is opposite of the right angle, and that's gonna be our hypotenuse. So that's gonna be this side right here. Ready? And I'm going to spell it off of my sheet because I grew up with spell check, unfortunately. And hopefully in every class I have like every year's spelling bee winner and they can help me spell things. Alright, so now that we have the hypotenuse down, we're going to look at these 2 angles. And every other side of the triangle is either called adjacent or opposite. So not regarding triangle, so what does the word adjacent mean?
Across from. Or no, beside.
Next to, right? Like, I am adjacent to this wall, right? All right, so if we're looking at our y, I'm going to label these just 1 and 2, so you guys can tell me. So I'm looking at my y, what side do we think this is? Adjacent or opposite? Adjacent, perfect. So, I know I only have 1 line there, but we're actually going to label what each one for each angle is. So this one is going to be y. Look at me spelling again, adjacent. I spelled that wrong. Alright, so our y adjacent. So this one must be our x adjacent, right?
This successful absorption of Austria to Germany in March of 1930.
Alright, so now we're at the easy one. Here, I'll kind of do our little arrow. So now we're at the easy one, right? So if our x is right here, directly opposite, this must be our x opposite side.
Russia's not invited to this conference due to the anti-Soviet rhetoric. So this leads into
there we go. All right, so if we're looking over here, if our y is right here, we go directly across. This must be our y opposite.
2 nations that hated each other or did not want to cooperate. Why would they cooperate?
All right, yeah, I'll kind of erase that so it doesn't get too cluttered. All right, so looking at this, now we have ways to describe our sides, which we need before we can kind of explain our ratios. So, since you've all kind of taken the ACT or whatever else, you've all seen Sakatoa before, I'm guessing. So, and that's written on here, and I color-coded it too. So it kind of breaks up where our ratios are. Okay, perfect. So, first we're going to look at saw, if you will. Okay, so that means sine. And before it's broken down into its abbreviation, it does have an E at the end, so if you're going to write it in a sentence, that's how you'd write it. But sine, like this, and we're always going to have some angle, right? It's a function, and its input always needs to be an angle, and the output is the ratio that we get. So for this one, I'm just gonna use theta. And a lot of times when we're working in trigonometry, our angles are gonna be Greek letters, but it doesn't matter what Greek letter it is. If it's a Y, I mean, we could have angle, smiley face, and it would not matter, they're just placeholders. Alright, so when we're looking at sine, that's gonna be the ratio of, if we're looking at angle smiley face, opposite over hypotenuse, which is already on your sheet. And you'll often see these abbreviated, or maybe even O over H, but all the same. Alright, now we're gonna look at cosine. Cosine, same thing, if you're gonna write it in the sentence, it's cos and then ine, but when it's abbreviated, it's just abbreviated like that. Again, we're gonna put a placeholder angle in there. And cosine is gonna be adjacent over hypotenuse. Alright, so if we're looking at angle smiley face, it's gonna be adjacent over hypotenuse. Alright? Now we're gonna look at TOA. Alright, so that's gonna be tangent. Alright, and so tangent is abbreviated TAN. We're gonna put another placeholder in, theta, is equal to, and then that's gonna be opposite over adjacent.
In compliance with the secret protocol, Stalin.
Alright, so if we're looking over here, this is the only one that doesn't involve hypotenuse. So if we're looking at smiley face, it'd be opposite over adjacent. Alright, so now all we're doing for this lesson, since it's kind of a short one, is we're going to be working with triangles and just writing out what all those are. Practicing pulling it off the triangle and putting it down. And then the next lesson of this would be taking this and solving for the actual angle and putting it into application. So I'm going to erase this since you guys have it, and I'll leave that up so we can use it. You also have it on your note-taking guide. And on the bottom of our note-taking guide, we have 2 examples. So I'm kind of going to write those down for us. I'll make sure this triangle is lined up the same for you guys. Alright, so our right angle's down here. Our bottom left-hand angle, I have as alpha. And I have this angle up here as beta. And then you guys don't have the numbers on there yet, so definitely gonna have to write these down in your note-taking guide so when you look back it makes sense. 4 and 3. And when you're doing a lot of trig, this is a triangle that'll come up a lot because it works out perfectly. What I mean by that is, we would have already learned this in our geometry class, but when we use Pythagorean's theorem, which is a squared plus b squared equals c squared, which is what we should test all of our right triangles with. Because if that doesn't work out, it's not a right triangle, and you can still write down all of this, but as soon as you try to start solving for that angle, it won't be right, because this only works for right triangles. So, when we are looking at this for our right triangles, a squared, let's use 3.
So,
Plus 4 squared
when was it signed?
equals 5 squared. That's
Yep. So
9 plus 16
Germany's
equals
relationship with the
25.
Soviet Union was.
And 25 does in fact equal 25. So that's why we use this one and the next one that we're going to do are perfect. So they don't, no decimals to worry about.
And then also common.
Alright, so first thing it asks us to do is identify our hypotenuse, adjacent, and our opposite. First, I want to focus on alpha to do this, okay? So, can somebody tell me what my hypotenuse is going to be?
Why was Joseph Stalin more?
3 or 4 or 5?
Just 5. Yep, we're just doing the sides right now.
So a couple of answers.
Perfect. Awesome. So if we're looking at alpha, what is my, what is my adjacent going to be? If we're looking at alpha. 3. Perfect.
So yeah, there's a couple answers for that one.
And what about my opposite side? What's that one going to be?
So he would be putting Germany.
4. Perfect.
France and Britain.
Alright, so now that we have all of these written out, let's go ahead and find our sine. And then we're focusing on,
In compliance with the secret protocol.
Oh, no.
to the Soviet Union.
So if you guys look there.
It's theta.
yeah, I put theta in there, but obviously we should probably do alpha because theta's not in our triangle. Sorry about that, guys, or we could switch it out the other way.
France. The pact was originally supposed to.
I'll
last
write it on the
10 years,
board
but how long
correctly
did it
for you.
actually last? Yep,
Alright,
two.
so using what we have over here and on your sheets, what is my sine of alpha gonna be?
Molotov. Can't say his name.
It's opposite over hypotenuse.
And there were executed.
4 over 5, perfect.
But then Molotov wasn't charged for
All right.
the full life.
So what's my
This
cosine
last
of
one,
alpha? It's going to be
kinda like
adjacent
a-
over
I
hypotenuse.
guess your guys' own answer.
3 over 4.
Preface that on there, but
Adjacent
I would
over
state that the
hypotenuse,
secret
right?
protocol, which we're
For
gonna talk
cosine,
about,
you're all good, you're all good.
was a
So 3 over
fabrication.
5 for that one. And
This is
then
basically the same phase.
4 over
Sort of
3.
like after World War II.
tangent's going to be 4 over 3.
You have basically.
Exactly.
just
So can you guys take a
Russia
minute and solve our sine, cosine, and
So,
tangent for our beta angle
trying
next?
to, save some face.
And then I'm going to have somebody come and write it on the board for me.
Yeah, and then, the dotted line at the bottom, we're gonna have for an axis step, so just hold on to that real quick. So I
Feel good about it?
the
I don't
text
know.
from
That's
Molotov
right.
about that. I wanted to have you guys.
Best way to learn math is to mess it up and figure out why. Alright,
Think
go
about,
for it.
like,
Yep.
we don't have to do this exercise, the pick an article exercise, just for time's sake, but, like key questions, takeaways, what do you guys think about it? What are the implications? Just a brief skim.
Perfect. That's awesome.
You spend a bunch of time on
Sweet.
it.
So we got 3 over 5 for our sine, 4 over 5 for our cosine, and 3 over 4 for our tangent. Does that make sense, everybody? Awesome. Sounds good. We're gonna do one more practice, and then I have a little activity for us to do. All right. So for our next one here, I'm gonna use another common perfect right triangle. So we have 17, 15, and 8. So can somebody tell me the hypotenuse of this triangle?
17.
17. Again, if we're focusing on alpha first, what is my adjacent?
Alpha is like this one, the A looking?
Yep, the A.
So 8.
In,
8, perfect.
I think on our paper it's
in our
different.
triangle, it's flipped over.
Beta and
Ooh,
beta's
thank
in
you,
the
thank
yeah.
you. Appreciate that. And alpha. Alright, so, sorry about that guys, thanks for the correction. So for our alphas here, then our adjacent is going to be 15. And our opposite will be 8. I'm gonna put that we did alpha for that. Alright, so I want you guys to go ahead and let's solve for our alpha first again for this one. And I'll write up the sine, cosine, and tangent, and then someone's going to come up and solve it. Alright, feel confident, Curtis?
Yeah.
Alright, come on up.
Common thread too, so, moving on, there's this part that's not added on here. because it
Oop,
wasn't
we're doing our
published
alpha
later,
first.
but there's
Oh, we're
this
doing
protocol.
Yep,
Now we're
that's
letting
right. I still
these
believe in you,
three
though.
work together. These basically, the gist of it is, it's saying spheres of influence for both Russia and Germany at the time, so, it's talking about political rearrangements of certain nations after either Germany or Russia takes over said nation.
Perfect. Alright, so for our sine alpha,
And then
we got
at the
8
bottom,
over
it's
17.
like this is
Cosine
strictly
alpha,
secret.
we
It's
got
just
15
the
over
same
17,
page,
and
just in
tangent
case
of alpha, we
something's
got 8 over
close,
15.
which
Does everybody agree with those?
Which it will.
Awesome, glad to hear it. Alright, so we'll do the same thing with beta. I know it's kind of
Yeah,
painful,
so
but
moving on
one of
to
the best ways to do
quick
these
discussion.
is repeat,
Why do
wipe,
you
and
guys think
repeat.
there
Alright,
would be
so
secret protocols?
I will go ahead and start writing them down here again, so I want you guys to do
Type
beta, and then I'm going to have you come up and do this one.
groups.
Okay. Sine beta, beta, and tangent.
Yeah, exactly.
Alright, Nick, whenever you're ready.
Yeah. Yeah.
5 minutes, it'll be 20 minutes. Fast, huh?
Okay.
So, yeah.
We'll get partway through our activity. when it does that.
How would-
Here we go, guys.
I guess how would you
We want to get one triangle done on this one, but it is a group activity, so should be good. And then Rachel, you can stop recording like once I just wrap this up.
Sounds good.
All right. So for sine beta, so sine beta is going to be opposite over hypotenuse. So it'll be 15 over 17. Over 17. And then cosine is going to be adjacent over hypotenuse. So you just had those flipped, so it's 8 over 17. And then tangent is opposite over adjacent, so 15 over 8. Or 15 over 8. Alright, so you can stop recording if you'd like, Rachel. Awesome.